started our discussion on calculation of calorific value of fuels. Okay, calorific value is nothing but the amount of heat energy liberated by burning 1 unit mass of fuel, and uh, the units of heat are calorie, kilocalorie, British thermal unit, and centigrade heat unit. And hence the calorific value is measured in terms of kilocals per kg, cals per gram, or if British thermal unit, BTH slash foreign heat. That's how they are measured. Okay, these are the units of the calorific value. And the interconversion values, 1 kilocal is equal to 1000 calories is equal to 3.9 British thermal units is equal to 2.2 centigrade heat unit. Okay, and these are the units of calorific value. Then we introduced ourselves to another important aspect. Okay, how this calorific value is measured? One, experimentally. That's the most important one. Of course, experimental calculation of calorific value is very important. And it is done in in calorimeters. Okay, generally for solid fuels, it is done in bomb calorimeter. Okay, for gaseous fuels, it is Junkers gas calorimeter. Okay, uh, gaseous or volatile liquid fuels. Okay, otherwise, voice calorimeter is one other instrument which is generally used for finding the calorific value of various fuels. I think you have studied this calorimeter in the intermediate. No, where in the syllabus? Okay, you don't know. You forgot. I understand that. Now, after understanding that, we'll focus equally on calculation of calorific value of various fuels theoretically. Just yesterday, I was like trying to tell you all that when calorific value of fuels is measured, it's also like theoretically we are calculating the calorific value of various foodstuffs which we are consuming. Due to the importance of fitness nowadays, fitness freaks have come up so much that they are very keen or choosy about eating such food which has less calorific value, rather more protein content. Okay, so nowadays, to the extent it has gone that the food supplements sometimes they give the calorific value of the quantity we are consuming. So how they are doing all these things? Each time they are not putting that material inside and they are measuring the heat evolved. Calorific value is made theoretical. Okay, so is the importance that we will measure using Dulong's formula. Okay, so is the discussion. Fine. So after understanding all these things, now I want to start measuring the calorific value of the fuels. Okay, so how it is calculated? How I'm going to calculate the calorific value? I'm going to calculate calorific value in two ways: high calorific value or gross calorific value. Next one is low calorific value or net calorific value. I think this is what we discussed yesterday. So calorific value is calculated in two ways. Okay, it's calculated as, first one is high or gross calorific value, given as GCV or HCV. Okay, whereas the other one is measured as low or net calorific value, LCV or NCV, or the abbreviations which are given for the purpose. Okay, after understanding this, we'll move to the next aspect. So what is HCV and LCV? If I'm finding the calorific value along with the condensation of the products, particularly H2O, then the the calorific value I'm measuring is called as gross or high calorific value. Now, high calorific value is measured uh, by burning the fuel in a closed vessel. What will happen? Generally, fuels contain carbohydrates. Carbon gets converted to carbon dioxide, whereas hydrogen gets converted to H2O. Okay, the H2O will be in the vapor state, obviously having more energy. But when the reaction is done in a closed vessel, obviously carbon dioxide does not condense, but H2O undergoes condensation. When H2O undergoes condensation, it will form liquid water. Along with that, it will give some heat energy to the system. How much heat energy? Latent heat of condensation of steam, which is 587 kilocals per kg. Okay, so when gross calorific value is calculated, it is not just the heat that is evolved when I'm burning the fuel. It is also the heat that is obtained due to condensation of steam into water. Okay, so high or gross calorific value. Low or net calorific value. How? It is just the heat energy evolved when a unit mass of fuel is burned. This is done in an open vessel, and the moisture that is coming out during combustion process will leave into the atmosphere. And hence, it is only the heat energy that is obtained during the combustion that is calculated as low or net calorific value. And we obviously, I told you that latent heat of condensation of steam is how much? 587 kilocals per kg. Okay. Therefore, high or gross calorific value will be equal to low calorific value, okay, or net calorific value plus 587 kilocals per kg or latent heat of condensation of steam. Now that is the formula. I think I stopped the discussion at this point. Correct? Antena? Or did I further discuss anything else? Okay. Now we'll move to the pin core area. Now, what is that core area? After coming to this formula, okay, I'll start calculating the calorific value of various substances. Okay. For that, I'll use Dulong's formula. Okay. So, the next important point which I'm going to discuss right now is, I've told you, experimentally, bomb calorimeter, Junkers gas calorimeter, and Boy's gas calorimeter, none are there in your syllabus. So, experimental method of calculation of calorific values is not there. Thank God. But what is there in your syllabus is theoretical calculation of calorific values. Write it. Theoretical calculation of calorific values, and the formula used is Dulong's formula. Formula used is Dulong's formula. Okay, hope the board is clear. Dulong's formula is used. Now, at this point of time, I will explain something. Please did not have to write in your book at all, but just listen to it. Okay. So, if I want to do theoretical calculation of calorific values, okay, what I need to have, what data I need to have in prior, just like if you're calculating E cell of any battery or E cell calculations if you're doing, what is the prior information you need to have? Huh? ఈ సెల్ క్యాలిక్యులేట్ చేయాలనుకుంటున్నావు, దానికి ఈ సెల్ క్యాలిక్యులేట్ చేయాలి అంటే ఏం ఇన్ఫర్మేషన్ నీకుంటే కంఫర్టబుల్ గా అవుతుంది చెప్పు? ఎస్ఆర్పి వాల్యూస్ ఉంటాయి. సో మనకి ఎస్ఆర్పి వాల్యూస్ ఉన్నాయనుకో దగ్గర, ఈ సెల్ వాల్యూస్ ఈజీగా క్యాలిక్యులేట్ చేస్తాం. జింక్, కాపర్, బ్యాటరీ, అదే డేనియల్ సెల్, అలాగా. సరే, అలాగా నువ్వు థియరిటికల్ గా నువ్వు క్యాలిక్యులేట్ చేద్దాం అనుకున్నావు కెలరిఫిక్ వాల్యూ ఆఫ్ ఫ్యూయల్స్. ఓకే, దానికి మనకి కావాల్సిన ఇన్పుట్ ఇన్ఫర్మేషన్ ఏంటి అంటే అబౌట్ ద calorific value of individual elements. Okay, what this is information for information. Okay, listen. If a fuel is there, okay, in hope you remember in the discussion about proximate and ultimate analysis of coal, what we found in proximate analysis, we found the moisture content, ash content, volatile matter content, and fixed carbon content. How much amount of carbon is there? And we understood that the carbon percentage dictates the calorific value of the fuel and hence is the quality. Okay, that's the first point. Just like that, we also wrote the information about the calculation of the percentage of carbon, hydrogen, nitrogen, sulfur and oxygen in ultimate analysis. గుర్తుంది కదా? సో ఒక కోల్ శాంపుల్ ని తీసుకుని దాని క్వాలిటీ ఆఫ్ కోల్ ని ఎలా అని చెప్తున్నావు? దాని calorific వాల్యూ అని. ఓకే, గ్రేటర్ ద calorific వాల్యూ, గ్రేటర్ ఇస్ ద క్వాలిటీ ఆఫ్ కోల్ అని చెప్పాం. సరే, ఆ calorific వాల్యూ దేని మీద డిపెండ్ అయి ఉంటుంది? కార్బన్ కంటెంట్ మీద ఆర్ కంబస్టబుల్ ఎలిమెంట్స్ కంటెంట్ మీద. సరే, సో ఒక కోల్ శాంపుల్ ని తీసుకుని దాంట్లో వేరియస్ ఎలిమెంట్స్ ఏమున్నాయి అని నేను ఐడెంటిఫై చేసిన అనాలిసిస్ ఏంటి? అల్టిమేట్ అనాలిసిస్. అల్టిమేట్ అనాలిసిస్ లో ఏం చేశాను? పర్సంటేజ్ ఆఫ్ కార్బన్, హైడ్రోజన్, నైట్రోజన్, సల్ఫర్ అండ్ ఆక్సిజన్ కనుక్కున్నాం. ఓకే, సో ఏం తెలుసు నాకు? గ్రేటర్ ద కార్బన్ కంటెంట్, గ్రేటర్ ఇస్ ద calorific value. ఓకే, సో వాస్ ద డిస్కషన్. అలాగా ఎనీ ఫ్యూయల్, వెదర్ ఇట్ ఈస్ gaseous fuel or whether it is liquid fuel or solid fuel, మనకి మెయిన్ గా కంబస్షన్ అయ్యి మనకి calorific value కి కాంట్రిబ్యూట్ చేసే ఎలిమెంట్స్ ఏంటి? ఫస్ట్ ఇంపార్టెంట్ వన్ is carbon. Okay, then I said hydrogen is also another element which contributes to calorific value, but not all hydrogen is available in the fuel for combustion. Some part of hydrogen reacts with oxygen to form moisture, which actually decreases the calorific value. Okay, so hydrogen also contributes to calorific value, but only available hydrogen alone contributes to calorific value. Okay, some amount of hydrogen which is already combined with oxygen to form H2O is called as fixed hydrogen or combined hydrogen that does not support combustion because it forms moisture and decreases the calorific value. Okay, so I'll explain that after 2 minutes. Okay, next, nitrogen is another element with which I have analyzed for. Nitrogen is neutral element. Okay, does not affect any combustion, does not affect combustion or calorific value. So we are not much bothered about this calorific value. Okay, so this option is lost. Sulfur is one such element which actually increases the calorific value, but the byproducts formed, the oxides of sulfur formed, are environmentally not very safe, and the sulfur itself reacts with the instruments or the operational material, forming iron sulfide and all, and causes corrosion. So its presence is not favorable but supports the calorific value. Okay, oxygen is actually the negative element. If oxygen is present in the fuel, it is not present as free oxygen, it is always present as combined oxygen. Okay, combined O2. How it is present in combined state? It quickly reacts with hydrogen to form H2O. Okay, which contributes to the moisture content. Okay, and decreases the calorific value. Okay, that is the discussion. In Japan, so theoretical calculation of calorific values నేను టార్గెట్ ఏం చేసినప్పుడు సరే ఎలా చేస్తారు అంటే ఫస్ట్ కంబస్షన్ ఆఫ్ ఇండివిజువల్ ఎలిమెంట్స్ ని చేస్తారు. అంటే ఒక కేజీ కార్బన్ ని తీసుకుంటారు లేదా గ్రామ్ కార్బన్ 1 యూనిట్ మాస్ ఆఫ్ కార్బన్ ని తీసుకుని బర్న్ చేసి అది ఎంత హీట్ ఎనర్జీని ఇచ్చిందో మెజర్ చేస్తారు. అలానే హైడ్రోజన్, నైట్రోజన్, సల్ఫర్ ని అలాగా తీసుకుని బర్న్ చేసి అది ఎంత హీట్ ఎనర్జీని ఇవాల్వ్ చేస్తుందో చూస్తారు. కానీ మనం ఇక్కడ ఒక ఫార్ములా రాసే ముందర ఏం గుర్తు పెట్టుకోవాలి? కార్బన్ calorific value ni dictate చేస్తుంది. మేజర్ ఎలిమెంట్ విచ్ కాంట్రిబ్యూట్స్ టు calorific value ఏంటి? కార్బన్. ఓకే, అండ్ సో ద క్వాలిటీ ఆఫ్ ఎనీ ఫ్యూయల్. సరే, సో ఇట్ ఈస్ ద బెస్ట్ ఎలిమెంట్ టు బి ఇంక్లూడెడ్ ఫర్ giving the calorific value of any element or any substance. Next, hydrogen తీసుకుందాం. Hydrogen is one such element which is partially useful, partially not useful. ఎందుకు? హైడ్రోజన్ ఫ్రీ స్టేట్ లో ఉంటే అది అవైలబుల్ హైడ్రోజన్ అంటారు. it undergoes combustion and contributes to calorific value. కానీ అంత హైడ్రోజన్ ఫ్రీ హైడ్రోజన్ కింద ఉండదు. ఎందుకు అంటే కొంచెం హైడ్రోజన్ ఏముంటుంది? ఫ్యూయల్ లో ఆక్సిజన్ ఉంటే ఎయిర్ నుంచి నువ్వు పాస్ చేస్తే అది కంబస్షన్ కి సపోర్ట్ చేస్తుంది. కానీ ఫ్యూయల్ లో ఆక్సిజన్ ఎప్పుడు ఉంటుంది తెలుసా? ఎప్పుడు H2O రూపంలోనే ఉంటుంది. ఫ్రీగా ఆక్సిజన్ ఉండదు ఫ్యూయల్ లో. ఏం చేస్తుంది? ఆక్సిజన్ బై ఛాన్స్ ఏదైనా ఉందంటే అది హైడ్రోజన్ తో రియాక్ట్ అయ్యి H2O ఫామ్ చేస్తుంది. ఈ హైడ్రోజన్ ఏదైతే రియాక్ట్ అయ్యి ఆక్సిజన్ తో H2O ఫామ్ చేస్తుందో దాన్ని ఏమంటామంటే ఫిక్స్డ్ ఆర్ కంబైన్డ్ హైడ్రోజన్ అంటాం. Fixed or combined hydrogen atom. Okay, and this is not available for combustion. Okay, and does not contribute to calorific value. Sorry, so discussion. So a hydrogen is partially useful, partially not useful. Okay, available hydrogen contributes to calorific value, whereas fixed hydrogen decreases the calorific value. Nitrogen is one element which is neutral. It does not affect the calorific value. Okay, sulfur is another element which contributes to calorific value, but its presence in the fuel is not favorable. First, it causes corrosion. Second, it causes pollution. Okay, just like the negative element, but still contributes. Okay, oxygen is always present in combined state with hydrogen as moisture. That's the discussion. Now, this is the introduction to my discussion. Okay. Now, after understanding this, what I should tell you is that now what they did, they burnt, I just know I told with you that when they burnt 1 kg carbon, okay, on combustion of 1 kg carbon, they got how much heat energy? 8080 kilocals per kg of carbon heat energy. Okay, this is HCV, kids. This is HCV. You need not have to write. This is for your know-how. Okay, when they burned 1 kg hydrogen, available hydrogen, it was 34,500 kilocals per kg. Okay, that much amount of gross HCV or GCV amount of heat energy that is burning in a bomb calorimeter they have done in a closed vessel. They got HCV or GCV. Okay, next. If they burnt 1 kg of sulfur, how many calories of heat they got? 2,200 kilocals per kg of heat energy they got. Okay. And then what they understood that neither nitrogen I need not have to include because it does not affect. Oxygen is never present in free state. So that is also ruled out. So they understood that for giving the Dulong's formula, the three elements that are required are carbon, hydrogen, and sulfur percentage. And the Dulong formula is given as. Now you start writing. Dulong's formula. HCV or GCV is equal to 1 by 100 into C into 8080 plus 34,500 into H minus O by 8, H minus O by 8 plus 2200 sulfur kilocals per kg. That's the Dulong's formula. That's the Dulong's formula. Hope the entire formula is clear to all of you. Okay. Now, after using this formula, have to give one more formula to you. What? HCV is equal to HCV or GCV is equal to LCV plus 9 capital H by 100 into 587 kilocals per kg. Okay, what you will get from Dulong's formula is HCV value. Okay, and that HCV value can also be obtained like this. How? In the last class I told you HCV is equal to LCV plus latent heat of condensation of steam. Okay, now what are these new values that are seen here is what I'm going to do the explanation. This is one formula in a block and this is another formula in the block. Important. We will start doing the numericals of this. Okay. But let me explain the contents. Just now I told you here capital C is the percentage of carbon. Okay. Capital C is percentage of carbon that is present in the fuel. 8080 is the calorific value that is obtained by burning 1 kg of carbon in a bomb calorimeter. That means in a closed vessel. Okay, that much amount. Here 34,500 is the hydrogen. The heat energy that is liberated by burning 1 kg of hydrogen, available hydrogen. Okay, what it means by available hydrogen? The hydrogen which can undergo combustion and give heat energy is called the available hydrogen. Available hydrogen is given by the formula H minus O by 8. Okay. Next, 2200 S means this is the amount of heat energy liberated when 1 kg of sulfur is burnt in a closed vessel. Okay. Here 22,240. Please edit. 40 is okay. Sorry. Just make the small change. 2,240. Yes. S is the element. Okay. Okay. Now, after calculation of HCV, I want to calculate LCV. LCV will be equal to HCV minus latent heat of condensation of steam. Okay. I hope you all have taken down the formula. Then I'll rub this and I'll start explaining how I got this. Or let me adjust the board in such a way that I can explain. Okay. So I said calorific value is nothing but the amount of heat energy liberated by burning of 1 unit mass of any substance. Okay. So what I told with you, capital H is the total amount of hydrogen that is present. Okay. So if you say if capital H is equal to the total amount of hydrogen available in fuel. Okay. In the fuel. Then some amount of hydrogen got reacted with oxygen to form fixed or combined hydrogen. That is O by 8. O by 8 is equal to the fixed or combined hydrogen. You can take down for your information. Fixed or combined hydrogen. Okay. Is nothing but O by 8. Already reacted. Already reacted to give H2O, moisture. Okay. Decreases calorific value. Okay. So H minus O by 8 is the available hydrogen. Okay. Which contributes to calorific value. Which contributes to okay. Now, okay. Did you write this? Now I will explain how I got this term and this H minus O by 8 how I got and 9H by 100 how I got. I'll explain. Now I have a question. Can anyone explain this to me? బోర్డు నుంచి రాసుకుంటున్నారా మీకు అర్థమవుతుందా అన్నది నా డిస్కషన్. ఇది ఎలా వచ్చిందో ఎవరన్నా చెప్పగలరా? వద్దు, బుర్ర ఎక్కువ వాడకండి, టైం కూడా లేదు. సరే, ఐఎమ్ నౌ రబ్బింగ్ ద బోర్డ్. ఓకే, just I'll move the board like this. Okay. I'm explaining this term, H minus O by 8. Fine. So, from the definition, what I've realized is that by burning 1 kg hydrogen, okay, some amount of moisture got evolved, okay, it underwent oxidation, okay, and it gave moisture, okay, which underwent condensation to form H2O, which actually condensed back to give the latent heat of condensation of steam. Okay, so I'll write first a stoichiometric equation, then I'll explain. Okay, so the point here is H2 reacts with half O2 to form H2O. Okay, that means if I take the weight, 2 kgs of H2 reacts with how much? O2 weight enta? O2 weight enta? What's the weight of O2 molecule? Hello? Are you listening to me? Is anyone there in the class?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
మీరు ఎస్ మ్యామ్ అంటున్నారేంటి? వినట్లేదా మీరు క్లాసు? అర్థం కాలేదా? చెప్పండి ఫస్ట్.
వింటున్నాం మ్యామ్.
వినడం కాదయ్యా, అర్థమైందా లేదా మీ అందరికి? గర్ల్స్, వాట్ ఈస్ దిస్? అసలు మీరు పవర్ బ్యాంక్ ఆఫ్ ద క్లాస్ ఆన్సర్స్ మీరే నుంచి ఎక్స్పెక్ట్ చేస్తా. అంటే కొందరు ఉన్నారు అబ్బాయిలు ఇస్తారు, బట్ మెనీ ఆర్ క్వైట్, బట్ గర్ల్స్ ఆర్ నాట్ రెస్పాండింగ్. ఐఎమ్ షాక్డ్. ఓకే, ఈ హెచ్సివి జీసీవి ఫార్ములా, డ్యూలాంగ్స్ ఫార్ములా అండర్స్టాండ్ అయిందా మీ అందరికి? దాంట్లో అండర్స్టాండ్ అవ్వడానికి ఏం లేదు, ఆ ఫార్ములా బట్టి కొట్టాల్సిందే. ఓకే, కార్బన్ ఎంత క్యాలరిఫిక్ వాల్యూ ఇస్తుంది? 1 kg బర్న్ చేస్తే 8080. హైడ్రోజన్, అవైలబుల్ హైడ్రోజన్ బర్న్ చేస్తే 34,500 కిలో క్యాల్స్ పర్ కేజీ ఇస్తుంది. అదే సల్ఫర్ అయితే 2240 టు బి మోర్ స్పెసిఫిక్. సరే, అది అర్థమైపోయింది. సరే, ఇప్పుడు ఆ H మైనస్ O/8 టర్మ్ ఏదోటి నేను ఎక్స్ప్లెయిన్ చేయాలి కదా, అది చేస్తున్నా. ఓకే, H మైనస్ O/8 లో చెప్పాను, హెచ్ అంటే ఏంటి? టోటల్ అమౌంట్ ఆఫ్ హైడ్రోజన్ అనుకుంటే హెచ్, దాంట్లో O/8 ఏంటి? ఫిక్స్డ్ హైడ్రోజన్, అంటే ఆల్రెడీ ఆక్సిజన్ తో రియాక్ట్ అయి మిగిలింది. ఓకే, ఆక్సిజన్ తో రియాక్ట్ అయిపోయిన హైడ్రోజన్ మాయిశ్చర్ ఫామ్ చేస్తుంది కాబట్టి క్యాలరిఫిక్ వాల్యూ డిక్రీజ్ చేస్తుంది. సో అవైలబుల్ హైడ్రోజన్ ఎంత ఉంటుంది? హెచ్ టోటల్ అయితే O-8 రియాక్ట్ అయితే H మైనస్ O/8 ఏమవుతుంది? అవైలబుల్ హైడ్రోజన్ అవుతుంది. సరే, అదే చెప్తున్నా. సో ఇది ఎక్స్ప్లెయిన్ చేయడానికి మీకు ఒక పాయింట్ చెప్పాలి ఇక్కడ. సరే, ఫస్ట్ ఫార్మేషన్ ఆఫ్ వాటర్, ఇది ఇలా చెప్తే బెటర్. ఓకే, H2 reacts with O2 to form H2O. ఓకే, సరే. So 2H2 reacts with O2 to form 2H2O. కరెక్ట్? బ్యాలెన్స్డ్ ఈక్వేషన్, ఇది బ్యాలెన్స్డ్. ఇప్పుడు చెప్పండి, ఇది కేజెస్ గ్రామ్స్ అనుకోండి. ఎంత వెయిట్? 4 grams అనుకుందాం, 4 kgs. సో 4 kgs హైడ్రోజన్ రియాక్ట్ అయితే ఎంత అమౌంట్ ఆఫ్, ఎన్ని కేజెస్ ఆఫ్ ఆక్సిజన్ తో రియాక్ట్ అవుతుంది చెప్పండి? What is the molecular weight of O2? చెప్పమ్మా.
32, ma'am.
32, correct. Okay, 16 2s are 32. So 32 kgs of O2 తో రియాక్ట్ అవుతుంది. To form how much amount of H2O? H2O weight ఎంత? 18. 18 2s are 36. Okay, so this is the weight equation. 4 kgs of hydrogen reacts with 32 kgs of oxygen to form 36 kgs of water. Okay. Now if I divide by 4, what I will get? 1 kg of hydrogen reacts with 8 kgs of oxygen to form any kgs? 9 kgs of water. Correct? Fine. Easy. You know it. Okay. So by this time I understood that 1 kg of hydrogen has a capability to form 9 kgs of water when it is combining with 8 kgs of O2. Okay. Fine. Now I'll set the equation. Okay. If H kgs of hydrogen is present in the fuel, then if H kgs of hydrogen is present in the fuel, how to do the calculations? The fuel has O kgs of oxygen. Then how to do the calculation? Okay. For 1 kg, it is 8 and 9 kgs. For H kgs, how much? H kgs of hydrogen is there, O kgs of oxygen is there. Then how to write the equation? Tell me. ఏంటి సింపుల్ మ్యాథ్స్ చెయ్యం ఏంటిది అసలే చాలా డిఫరెన్షియల్ ఈక్వేషన్స్ మా మ్యాథ్స్ ఏంటి మీరేంటి క్వశ్చన్స్ ఏంటి 4th 6th 7th క్లాస్ ఎల్కేజీ క్వశ్చన్స్ అడుగుతున్నారు అంటే నా సబ్జెక్ట్ కి అంతే చాలు సరే ఓకే సో ఫ్యూయల్ లో O kgs of oxygen ఉందనుకున్నాం. I have O kgs of oxygen in the fuel. Okay. I told you this O kgs of oxygen is never present just like that. What it does, it reacts with the hydrogen to form moisture. Okay. So what I'll say, 1 kg of hydrogen is there. Okay. It will react with how many kgs of oxygen? How many kgs of oxygen? 8 kgs of oxygen. Okay. If O kgs of oxygen is present in the fuel, then it will react with how much amount of hydrogen? Okay. O into 1 divided by 8. Hydrogen and రాయాలి. Correct? O into 1 divided by 8. That is equal to capital O by 8. Okay. Where O is nothing but the total amount of oxygen that is present in the fuel. And 8 is the amount of oxygen required for 1 kg of hydrogen. Okay. That's how I can measure the fixed hydrogen. This is the formula for fixed or combined hydrogen. Okay. Is the point clear? ఏం చెప్పా కార్బన్ అయితే గొడవ లేదు, సల్ఫర్ ది గొడవ లేదు, అసలు ప్రాబ్లం హైడ్రోజన్ తో వచ్చింది. సరే హైడ్రోజన్ కొంచెం ఏమో ఆక్సిజన్ తో రియాక్ట్ అయ్యి మాయిశ్చర్ ఫామ్ చేసి క్యాలరిఫిక్ వాల్యూని డౌన్ చేస్తుంది. ఇంకొంచెం పార్ట్ ఆఫ్ హైడ్రోజన్ ఏదైతే అవైలబుల్ ఉందో ఫ్రీగా అది కంబస్షన్ అయ్యి క్యాలరిఫిక్ వాల్యూకి కాంట్రిబ్యూట్ చేస్తాం. సరే హబ్బా. సో ఇప్పుడు టోటల్ హెచ్ కేజెస్ ఆఫ్ హైడ్రోజన్ ఉందనుకున్నాం. సరే హెచ్ కేజెస్ ఆఫ్ హైడ్రోజన్ ఉంది అనుకున్న తర్వాత అది ఎంత కంబైన్డ్ అయి ఉంది, ఎంత అవైలబుల్ ఉంది ఫస్ట్ కనుక్కోవాలి. సరే సో డ్యూలాంగ్స్ ఫార్ములాలో అది రాసా 34,500 ఇంటూ హెచ్ మైనస్ ఓ బై 8. అక్కడ క్యాపిటల్ హెచ్ ఎంత ఈజ్ ద టోటల్ అమౌంట్ ఆఫ్ హైడ్రోజన్, వెదర్ ఇట్ ఈస్ ఇన్ ద కంబైన్డ్ స్టేట్ ఆర్ in the free state, available state. If I take the total hydrogen as capital H, then I am getting the available hydrogen from that. How to get the available hydrogen? Okay, total hydrogen minus combined hydrogen is equal to available hydrogen. Now, how much amount of combined hydrogen is there? I have got to the formula. Which formula? In the first instance, I wrote this equation. This is for my know-how, for calculation. I know that 4 kgs of hydrogen reacts with 32 kgs of oxygen to form 38 kgs of water. Okay. And I have concluded the discussion that 1 kg of hydrogen reacts with 8 kgs of oxygen to form 9 kgs of water. Okay, I used this concept here. So if 1 kg of hydrogen is combining with 8 kgs, and if the fuel has O kgs of oxygen, then how much amount of hydrogen might have reacted? O by 8 amount of hydrogen might have reacted. That's how I got the formula for fixed or combined hydrogen. Okay, now obviously if total hydrogen is capital H, then O by 8 is the fixed hydrogen. Total hydrogen minus combined hydrogen is equal to available hydrogen. Okay, so this is fixed hydrogen. Capital H is total hydrogen. Okay, then the available hydrogen is equal to H minus O by 8, where here capital H is total hydrogen, capital O is total amount of oxygen that is present in the fuel sample. Okay, this part I'll erase. Now I'll get back to the next one. After the Dulong's formula and after the discussion on fixed hydrogen, available hydrogen, and total hydrogen, I'll now boil down to the next equation I have written on the board. I have written that HCV is equal to LCV plus latent heat of condensation of steam. Okay, so I'll have to understand what it is. So if 1 kg of hydrogen is present, okay, it is forming 9 kgs of H2O, which is undergoing condensation to give latent heat of condensation of steam. How much? 587 kilocals per kg. Okay. Now, if H kgs of hydrogen is present, then it will give how much amount of H2O? 9 into H divided by 1 kgs of H2O, which is nothing but moisture will be given. Okay, if I know that for 1 kg of moisture, the latent heat of condensation of steam is 587. Therefore, for 9H, it will be equal to 9H into 587 kilocals per kg. Okay, this is what it is. Why I have divided by 100? For percentage calculation. Okay, now did you understand how I got this formula? Okay, HCV or GCV is equal to LCV plus 9H by 100 into 587 kilocals per kg. This is the formula. This is what it is. Okay, no doubts, I think, because I hope you all can understand this much better. Okay, shall I start with the numericals? Please, if you have any doubt, ask me, because you are spending good time in the morning on a Sunday morning. you're spending good time with your chemistry teacher. So please do understand the value of time you're extending. Okay, so these are the terms that we are using in this particular calorific value calculations theoretically using Dulong's formula. Take down the numerical. Okay, so fixed hydrogen or combined hydrogen, total available hydrogen, and the total hydrogen are the concepts that you need to put into your head. Easy one. They'll not be fussy on this front. Okay.